Alright. I did send y'all a couple of emails yesterday.
There you go.
Wait.
What
You said
happened
what?
yesterday?
What?
I sent y'all a couple of emails.
You
You
don't
sent
got
the emails about the spring break tutoring things?
I
yeah.
did.
You did.
And a
Job
job
fair.
fair.
Yeah, you did.
Y'all actually read some stuff.
No,
I did.
I saw it. I saw it.
I sent you three.
Online. I make you feel good.
I sent you 3 emails and about the video lecture.
I'm gonna be honest, I didn't look at none of those.
Hold on, let me, I don't think I can get all this, I
Getting cramps. Well,
don't think it'll let me copy
well,
it
I
and
was just trying to
paste.
get you
Let me do it in multiple.
good.
I'll just show it without copying it. All right, y'all, today, there is a job fair from 10 until 2 at SIMT, so if you are interested, they sent us an email yesterday to the faculty of who all is going to be at the job fair. So I just forwarded that to y'all to kind of let you know who to expect. And it's just a wide array of people. I'll make it bigger so that you can kind of see. I mean, it's just a little bit of everybody. And there's like 80-something people that's going to be there. So if you're interested, and you do have this email, you can pull it up in your Alex when you get downstairs, or you can pull it up on your personal email. So all of these places are going to be at the job fair today. So that's the first email that that I sent you, was the one about who's going to be at the job fair. The second email that I sent you was the tutoring hours over the spring break week. So, we do not have classes next week. The tutoring will be open if you need to catch up. Now, if you are not doing geometry yet, if you are still in decimals and proportions, we probably need to play catch up next week. So, these are some hours. They're open or you can work from home. But remember, they're just like working from the hub. You just work and you ask a question if you have a question. So those are the hours that the hub will be open for tutoring. And it's the room right next to where we go to hub. Then I sent you the video, like I have been, of what we do in here, just if you want to look at it. Yay? All right. So that takes care of that. No classes next week, so I will not see you again until Monday the 18th. But that does not mean that you're going to go without doing Alex, because 75% is where you need to be by the end of the month. 75% or higher by the end of the month. All right. Now, we have about 17 pages left of geometry stuff. And then when we come back, we'll have the measurement stuff. The pints, the quarts, the kilometers, the hour, days, hours, whatever. Some of this stuff I'm going to go through kind of quickly because some of y'all have seen it. Again, if you haven't seen it, we need to be paying attention and not on our phones and not on our computers. Because even if you're not in geometry yet, when you take your knowledge check, you can test out of some of this stuff. Okay? So, angles, triangles. There are 3 types of triangles. If you have a triangle where all the angles are baby, this is an acute angle, this is an acute angle, and this is an acute angle. So if all the angles are acute angles, acute, 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 we call that an acute triangle. Remember, acute little puppy, acute little baby. So if they're all acute, we call it an acute. Now, if you have a triangle that has a right angle, we call it a right. Now, it's still going to have 2 of the acute angles. But as long as it has 1 right angle with the 2 acutes. Now, I have some people say, why does it have 3 right angles? Okay, if we have a right angle here and we have a right angle here, how many sides are on a triangle? Well, I've already drawn 1, 2, 3, and it's not a triangle. So in order to have a triangle, you have to have 3 sides. So if I draw a right angle, the third side has to be to close it up. So you're always going to have 2 acute sides, or 2 acute angles, and then the third one's the one that's going to decide. Obtuse, it is going to have an obtuse angle, and then we're going to close it up. So we're going to have 2 baby angles with an obtuse. So you're always going to have at least 2 baby angles. If they're all babies, we call it an acute. If it's 2 babies in a right, we call it a right triangle. If it's 2 babies in an obtuse, we call it an obtuse triangle. Okay? So we can't have all 3 obtuses, y'all, because if I drew obtuse here and an obtuse there, I wouldn't have a triangle. So, if I give you some examples, what are we going to call this first one? Acute, because this is a baby angle, this is a baby angle, and this is a baby angle. For the next one, what is that going to be? We have a baby, and then a big. So this one's going to be obtuse. What is the next one?
Right.
Baby, baby, and then a right. So this one's going to be a right triangle. The next one is a baby, and
What big one, so it's up to?
so it's an obtuse. So they're not bad as long as you know what you're looking for. Now, the next 3 things that you need to know, and then we'll get rid of them down here and talk about them up at the top. What we just did was triangles based on the angles, the inside. Now we're going to talk about triangles based on the sides. Now, if none of the sides were equal, no equal sides, we call it a scaling. Now, the way that I remember that, fish are scaly. Fish don't look anything alike. So all fish are different. They're scaly, they're ugly. So a scaling is when all of them are different. Then we have, if you have a triangle where 2 sides are the same, so like 5, 5, and 4. That is an isosceles. The 2 S's in isosceles remind me that there are 2 equal sides. So if 2 sides are equal, it's an isosceles. If no sides are equal, it's a scaling. Ugly scaling, nothing's equal. 2 S's are for 2 equal sides. If all sides are equal, we call it an equilateral, meaning equal sides. Now, so that's 3 equal sides. Now, this is the only book that I've ever seen done like this. If it is an equilateral, it is automatically an isosceles also. So, if it's an equilateral, it is an isosceles. This is the only book that I've ever seen done like this. So, we're looking at the sides, not at the angles. So, look at them and tell me how many are equal. Is 1 equal, 2 equal, or 3 equal? So none of them are equal. So what kind of triangle is it?
Fishy.
Fishy. That's how I think about it. Now, how many are equal on the next one?
Cheap.
2 are equal. So I have 2 S's, so that's an isosceles. Here, 3 are equal. So if it's an equilateral, we automatically call it an isosceles. What's the last one going to be? Just an isosceles because 2 are equal. Cool?
Cool.
All right. Now, I have some people that love Venn diagrams and I have some people that hate Venn diagrams. Okay? Either you get them or you don't. Huh?
She brought up. So what the third one is? The third one is you got like two.
These are the people who play, you may have tested out of it like in the very beginning. These are the people who play basketball. These are the people who play softball. So the blue play softball, the yellow play basketball, so the green are the ones that play both. And that's like my daughter. My daughter's a cheerleader and my daughter plays soccer, so she's on multiple teams. But there's some people that just play softball. And there's some that just are on the cheerleading team. But there's some that do multiple sports. So, how many people play basketball? So my basketball is going to be, if they are on the basketball team, I've got to count them. So 1, 2, 3, 4, 5, 6, 7. Y'all with me?
Yeah.
How many people play both sports?
Two.
2. That's going to be the overlap. How many people play softball but not basketball? So they're on the softball team, but they don't play another sport.
So it's 6.
1, 2, 3, 4, 5, 6. So yellow is just basketball. Blue is just softball. And green is both basketball and softball. Cool? Alright. Now, you need to know what these shapes are. A parallelogram, a rectangle, a square, and a rhombus. Now, most of you know the two middle ones. You know that a rectangle has opposite sides that are equal. So the left side and the right side are equal, the top and the bottom are equal, and you also know that a rectangle has 4 right angles. So most of you know that shape. Most of you also know what a square is. A square has all equal sides, and it has all right angles. So those are two shapes that y'all are familiar with. Most of you have no idea what what a rhombus and a parallelogram are. A parallelogram is a squished rectangle. So if you have a box and you sit on it, that's going to be a parallelogram. It's like a box that's leaning to one side or the other. So a parallelogram can look like that. A parallelogram can look like that. So it's like lean to one way or lean to the other way. That's a parallelogram. So the left is still equal to the right. The top is still equal to the bottom. Left is equal to the right, top is equal to the bottom. But it no longer has right angles because you sat on it. A rhombus is a squished square. So same thing, the only difference is you sat on a square box. So top, bottom, left, and right are equal. Or I can squish it the other way. Top, bottom, left, and right are equal. But it doesn't have right angles because you sat on it. Now, I didn't put in here the trapezoid. A lot of y'all don't know about the trapezoid either. The trapezoid looks like the top of Pizza Hut. The trapezoid has 2 lines that are parallel and the other 2 sides that are not. So these 2 sides are parallel and the other 2 sides are not. That's the only definition of trapezoid. So, now that we kind of know what they look like, it's easier to answer questions about them. So, first question. They're asking about a rhombus. A rhombus is a squished square. So it looks like that. Now, you're only gonna pick one of these. Are there two sets of parallel sides, or are there one set of parallel sides? Is the top parallel to the bottom?
Yes.
That's one set of parallel sides. Is the left parallel to the right? So that means there's two sets of parallel sides. And you're only going to choose one of those. You're not going to choose both. Now, congruent is a fancy name for equal. Are all four sides equal? It is a squished square. What do we know about a square?
Everything is equal.
All sides are equal. So are all sides congruent?
No, ma'am.
Yes, because a square has all equal sides.
Oh, yeah.
Does this shape have four right angles? Okay. It's squished. If you sit on it, is it going to have right angles?
No.
No. Now, let's look at the next shape. The next shape is a square. A square has four right angles with all equal sides. Two sets of parallel sides or one set of parallel sides? Top and bottom are parallel, left and right are parallel. So two. So what I'm saying is this is parallel to this, and this is parallel to this. That's why there's two. Are all sides congruent? Are all four sides the same length? Yes, because it is a square. Does it have four right angles?
Yes.
Yes, because nobody sat on it. All right, a parallelogram. That is a squished rectangle. Left and right are equal, top and bottom are equal. Does it have one set or two sets of parallel sides? Two sets. The top and the bottom are parallel, the left and the right are parallel. Are all sides congruent? Are all four sides the same length? No. Y'all see why? Is this side the same length as this side, the same length as this side, the same length as this side?
No.
No. Does it have four right angles? No, because it's been squished. Now, the other two that they may ask you about is the rectangle and the trapezoid. So let's look at the rectangle next. This is what my rectangle looks like. Left and right are equal, top and bottom are equal. One set or two sets? Two sets. Are all sides congruent? No. Does it have right angles? Yes. Now, the trapezoid is the one that looks like the top of Pizza Hut. One set or two sets of parallel? One, because this is parallel to this and the other two are not. So that one has one set of parallel. Does it have all sides that are the same length? Does it have four right angles? So all it has is one set of parallel sides. That's it. So you have to understand what the shapes look like before you can really answer the questions. And a lot of y'all got through that just by taking a picture of the example and answering the questions.
I did.
You did?
Yeah. I did.
Just like writing notes.
All right, let's look at another one. Now, this combines two different problems. Area, we know is length times width. Perimeter, we know is add up the sides. We've already talked about that in the past. We also know that area is going to be inches squared, feet squared, yards squared, miles squared. Perimeter is going to be inches, feet, yards. It's going to be plain. They also want you to realize that area is inside the shape. Perimeter is outside the shape. Even the word perimeter has rim around it, so it reminds you that you're doing the rim of the shape. So area is going to be like the grass in your backyard. Perimeter is going to be like the fence around your backyard. So area is inside, perimeter is around. So they gave you a problem and they want you to find the perimeter and the area. So for area, we're going to do length times width. For perimeter, we're going to add up the sides. So if this is my shape, my length is 37, my width is 66, so my area is going to be 37 times 66. When I add up the sides, I've got to do 37 plus 66 plus 37 plus 66 because it's a rectangle. 37, 66, 37, 66. And of course, I forgot to pull up my calculator when I was pulling everything up. Come on. And they also want to make sure not only can you do the problem and understand what the problem is, they want to make sure that you can do the units as well. So let me get it. So for the first one, we're doing length times width. So it's going to be 37 times 66. And the next one is 37 plus 66 plus 37 plus 66. So there's my two answers. What kind of units am I going to put on the area? Inches squared, that's my area. And my perimeter is going to be 206 inches. Now, the next one is making sure you know what you're doing. If we break the glass, what kind of problem is that? Perimeter or area? If you break the glass, that is area. If you have to replace the wire around the glass, that's going to be the perimeter. So area is the inside, perimeter is the outside. So if we have a glass and we have to fill in the glass, that's area. If we have to replace the wire around the glass, that's going to be my perimeter. Good?
Good.
All right. Now, a couple of area formulas that I haven't gone over completely with y'all, and I want to make sure y'all understand. Let me get my camera. There we go. Let me go to our formula sheet. We start using our formula sheet hot and heavy in Module 3. All right, when you're doing area, you have to know what the shape is. So right here, they're telling me this is a triangle. So I'm going to use my triangle formula. The formula says 1/2 base times height. Your base is what you sit on. So what is my base in this problem? 18. So 1/2 times 18. What would my height be? 5. I have a lot of people that want to tell me 13. Your doctor does not measure your height like this. Your height is always straight up and down. So my height is always going to be straight up and down. So when I go to my calculator, I am going to wrap up the fraction. Times 18 times 5. So my area, and because it's area, my units are going to be square whatever, square centimeters. Let me copy. I'm going to run through a couple more of these.
So on that one, you was trying to find the area, right?
Mm-hmm. Find the area. So what are we going to do with this one, y'all?
Base is 6, and the height is 5.
You got two different areas.
2 different areas.
We've got 2 different areas.
Yeah.
Right.
So what are our different shapes?
Triangle,
Triangle
square.
and square.
No.
Are we adding the shapes or are we subtracting the shapes? is when you glue things together. Subtracting is when you cut them apart. So, if I was adding, it would be a rectangle plus a triangle. So if you are adding, you take the whole rectangle and the whole triangle and you glue them together. That would be an adding. A subtracting would be take your rectangle and take away your triangle. So this one is going to be a subtracting. We're taking away a shape. So we start with our outside shape minus our inside shape. So what is my outside shape? What shape is it? A square or rectangle. And what's my inside shape? A triangle. So my rectangle formula is length times width. My triangle formula is 1/2 base times height. And I'm subtracting because if I was adding, it would look like that. So if I start with my outside shape, what is the length and width of my outside shape? 5 and 6, which is 30. Now, for my inside shape, which is here, that's my inside shape. Some of you, I'll just take your head and kind of turn it cattywampus, but it's easy for me to do up here. I'm going to take it and kind of show you off to the side a little bit. If I take that inside shape and I turn it a little bit, can you see that for my triangle, this is going to be my base, and this is going to be my height? It's easier to see when I can physically turn it, or you can turn your head and kind of say, oh, there's the base and there's the height. So when I do that in my calculator, what's 3 times 4?
12.
What's half of that?
6.
So 30 minus 6 is going to give me 24, and because it's area, my units are going to be squared. Isn't that fun? I love those.
And this is in model 3.
This is module 3. Yep. And everything that I do, I put out there under instructor resources, lecture notes, and I also send you the video. All right. Let's look at this one. It tells you in the directions to find the area of the parallelogram. We now know that a parallelogram is a squished rectangle. But I also have the formula right here for a parallelogram. The formula is base times height. What do you think my base would be? My base is going to be 11, and because I told you that a parallelogram is a squished rectangle, that tells you that the top and the bottom are the same. So my base is going to be 11. What is my height going to be? 10, because your height is always straight up and down. So 11 times 10 is 110, and because it's area, my units are squared. Alright, here they're telling you what the shape is. The shape is a trapezoid. Here is my formula for a trapezoid. The formula is A equals 1/2 times H times parentheses A plus B. So, what do you think my H is going to be in this formula? 7. Have you noticed we never use the diagonal lines? They're just there to confuse you. Now, A and B are your parallel sides. A and B are your parallel sides on a trapezoid. It doesn't matter which one you call what, because 3 plus 15 and 15 plus 3 are the same thing. So A and B are always your parallel sides. So when I go to type this in my calculator, I wrap up the 1/2, because it's a fraction, times 7 times, and then the 3 plus 15 has to be wrapped up because the formula told me it needed to be wrapped up. So the area for the trapezoid is 63, and because it's area, my units have to be squared.